Self-monitoring and reporting technology, SMART, failure. Imagine you are driving down the highway and a light on your dashboard pops up telling you that your tire pressure is dropping rapidly. You have not gotten a flat tire yet, but the car is warning you that if you do not pull over right now, you are going to have a major blowout. In the world of computer storage, there is an exact equivalent to this early warning system, and it is called self-monitoring analysis and reporting technology. When you're studying for your CompTIA A+ core, one exam to troubleshoot drive and redundant array of independent disks issues, you absolutely must understand how this diagnostic system works. It is the most powerful tool you have to prevent catastrophic data loss before the drive actually breaks. To get your perfect score of 900, you have to understand the microscopic metrics this technology is tracking and exactly what you must do when it throws a failure warning. Let us take a deep technical dive into where this technology lives and how it operates. This technology is not a piece of software you install on Windows or Mac. It is a highly complex diagnostic firmware permanently coded directly into the tiny controller microchip attached to the bottom of every modern mechanical hard disk drive and solid-state drive. From the very second the storage drive rolls off the factory assembly line and is powered on for the first time, this firmware begins meticulously recording every single thing the drive does. It acts exactly like an airplane's black box. For a traditional mechanical hard drive with spinning magnetic platters, the firmware tracks physical mechanical properties. It records exactly how many milliseconds it takes for the spindle motor to reach its maximum revolutions per minute, which is called the spin-up time. It also records the raw read error rate, which climbs higher when the tiny metal read and write head struggles to accurately read the magnetic charges on the platter. However, the absolute most critical metric you must know for the exam is the reallocated sector count. When a mechanical drive detects a microscopic physical scratch on the magnetic platter, it knows that specific sector is permanently dead. The drive's controller takes the data, moves it to a healthy spare sector hidden at the very end of the disk, and permanently retires the broken sector. This is called a reallocation. A perfectly healthy drive might have one or two of these over its entire lifespan. But if the reallocated sector count suddenly spikes to 50 or 100, it means the magnetic platter is rapidly degrading, and the read head is essentially scraping the disk to death. For modern solid-state drives, which have no moving parts, the firmware tracks entirely different physical metrics. It closely monitors the total terabytes written and the wear leveling count. Because the microscopic flash memory cells inside a solid-state drive physically degrade every single time you erase and rewrite data, the firmware actively counts how many write cycles each cell has endured. When the cells begin to completely burn out and lose their ability to securely hold an electrical charge, the available spare blocks attribute will rapidly drop toward zero. On your certification test, you will be presented with scenarios where a user's computer displays a black screen during boot with a terrifying text message stating that the status is bad, back up, and replace. This error message is triggered because the motherboard's basic input-output system queries the drive's firmware during the power-on self-test. If any of those critical tracking metrics have crossed the maximum safety threshold set by the manufacturer, the drive is screaming for help. This is known as a predictive failure. The most important concept you must grasp is that a predictive failure warning does not mean the drive is entirely dead yet. The drive is usually still spinning, the operating system might still load, and the user's files are likely still accessible. It simply means the drive is mathematically guaranteed to suffer a total, catastrophic hardware failure in the extremely near future, sometimes within hours or days. As an information technology professional, your troubleshooting response to this failure warning must be immediate and extremely cautious. Your absolute first and only priority is to back up all of the user's critical data to an external storage device or a secure cloud server. You must never attempt to run heavy software diagnostic tools like a disk defragmenter or a full surface sector scan on a drive that has thrown this predictive error. Running these intensive processes forces the failing mechanical parts or degrading flash memory cells to work at their absolute maximum capacity, which will almost always push the dying drive over the edge and cause it to fail completely while you are blindly trying to test it. Once the data is 100% safely backed up, the only correct professional repair is to completely physically replace the failing storage drive with a brand new unit, reinstall the operating system, and restore the user's files. By understanding the intricate firmware metrics tracked by this technology and prioritizing immediate data evacuation over software repair attempts, you will confidently master the storage diagnostic questions on your exam.